Hello, 6th grade students. So today we are continuing our discussion on continental drift. Very exciting stuff. So let's review. What are continents? They are large land masses, yes. And what is Pangea? It is that one large land mass before it split. And who proposed the idea that Pangea existed? Alfred Wagner. Okay, so now we've reviewed some things. I posted this reading for you guys. I am not sure if you've read it yet, but if you have not, please go back and give it a look. We're going to be talking about this reading for this lecture, and it would just be helpful for you to have that knowledge before we begin. So, if you have not done that, pause the video and go and read this. There's also a read to me feature, so if you feel like you need some help with reading, you can press on that and it'll be great. So let's start. So Alfred Wagner, we said, proposed the idea of Pangea, that all of the continents were once one. They were all together. So how did he come to that conclusion? Well, we talked about how they fit together like jigsaw puzzle pieces, and we did a puzzle. So that was one form of evidence, was that the shape of the continents look as though they fit together and create one piece of land. So the shape is one piece of evidence. But in science, we want to have more than just one piece of evidence to form a concrete theory or idea. So Alfred Wagner, he did what he could to look for other pieces of evidence. So let's talk about some of those pieces of evidence. One of which were mountain ranges. So the book talks about it here, where you have mountains in South America and mountains in Africa. And we said how these look like they fit together like a jigsaw puzzle. But the interesting thing is that they have the same type of mountains. They both have folded mountains. So it's as if this was one mountain range that drifted apart, that split apart. So it's the same type of mountains in both of these. So if this was all together one continent, it would make sense for this to have one mountain range on both continents. Okay, so we talked about land features. Land features, that means mountains. Mountains is land feature. Coal beds, that's another land feature that Alfred Wagner noticed. It was that there are coal beds throughout the continent. So you see in North America and Eurasia. Eurasia is a combination of Europe and Asia. So you can hear it in the sound, Eurasia. But there are coal beds in North America and in Europe, and it looks like they're exactly the same. They're the same type of coal beds. So that was the same as the mountains, where it's like, okay, we have these two things that are very similar, but now they've drifted apart. But maybe they grew and were established all together at one point. So that's what he was thinking about, those land features. Then, so we have land features and we have shapes of continents as two forms of evidence. Now, that still was not enough evidence. He wanted more evidence, so he looked at fossils. What are fossils? Fossils? Well, let's read in the book so we can practice that. A fossil is any trace of an ancient organism that has been preserved in rock. So, let's say you have this Glossopteris, and so that was that fern-like plant, right? And it turns into a rock, and it's just staying there. And then it, over years, you get piles and piles of dirt that come over it, and but that fossil, the imprint of the fern in a rock, it stays there. So that shows that fern, wherever you see that fossil of a fern, the Glossopteris, that shows that that's where that fern once lived. So it might not be there today, but if you see a fossil, it means that that thing that's impressed in the fossil, impressed in the rock, was there living at that location at one point. Because years and years add things on top of, add dirt and rocks and everything on top of the fossils. So it's not like somebody's collecting fossils and moving them. So that's the idea with fossils there. So if you find fossils, which are those rocks with embedded images of ferns, right? If you find those in South America, in Africa, in India, in Australia, in Antarctica, like it says for the Glossopteris fossil, that means that this fern was able to grow in all of those regions at some point. But could that happen today? No, it couldn't happen today because Antarctica is way too cold to support life of the Glossopteris fern. But there are fossils of it in Antarctica, which tells you that maybe Antarctica was a little bit closer to the equator and could support the life of ferns. Because right now Antarctica is too cold for that. But maybe in the past it was warmer and could support the life of those ferns. And it's also in Australia and Africa and South America, which now are quite spread apart. But if they were all together, like in this picture here, you would be able to see that the fossils could have all grown in the same region. And then it spread apart. So that's the example of fossils. That's the concept behind it. So there are other fossils other than the Glossopteris, the Lysosaurus and the Mesosaurus fossils. Lysosaurus and Mesosaurus. I don't know. Maybe let's see if we can focus this. It's okay. As long as you can see the map, you'll be able to follow. So the Lysosaurus fossil, it's this little guy here. So you have this imprint of this creature in a rock. So let's say this creature dies and is imprinted in a rock, and then layers of dirt fall on top over years. And you find this. You dig up a fossil of the Lysosaurus, and you find it in Africa and Asia. Well, usually, and in Antarctica. Usually, when you have one creature, it needs the same type of environment to live. So think about any creature, like a deer. What do deers need to live? Or what do deer need to live? It's not deers. So they would need a forest. They need water. They need what kind of environment? Yeah. So when you think of the environment for a deer, you're thinking, well, all deer need an environment like this. Every creature, whether plant or animal, has an optimal environment. That means it has an environment that it's best suited for. It needs a certain type of environment. So with this, let's look at this. You have the Lysosaurus fossils. So saying that Lysosaurus, they've lived in Africa, Asia, and Antarctica. Well, now that wouldn't make sense because this creature needs the same type of environment to live in. So you have Africa, Asia, and Antarctica. Well, right now, that wouldn't give you the same type of environment for this creature. This creature needs that same, that optimal environment. But if you look at Pangea, it would make more sense that this creature lived in this region here, where it has its optimal environment in this region of the Earth. But when they're spread out, and Antarctica is way cold, and India and Africa are warmer, well, this creature couldn't live in all three of these regions today because it's not its optimal environment in all three regions. Is that making sense? I hope so. So that's the idea with fossils. All of these creatures had to have been found in one place because they need that one optimal environment. Now, let's move on to climate. So the book says the continent carries with it fossils and rocks that formed at its previous locations. For example, fossils of tropical plants are found on Spitsbergen, an island in the Arctic Ocean. Let's think about this. So if you see fossils in the Arctic Ocean, so the Arctic's way up here, which is cold, the North Pole, the Arctic Ocean, you see fossils of tropical climates. Where are the tropics on the Earth? Well, you know that the tropics aren't in either of the poles because those are extremely cold. So the tropics are closer to the equator, somewhere around here, a little bit above the equator and around the equator. And the Earth is warmest at the equator. So if you find fossils of tropical plants in the Arctic Ocean, it would suggest that whatever was in the Arctic Ocean was once closer to the equator. So let me say that again. If you find a fossil that is a tropical plant, and you find it in the Arctic Ocean, what does that mean for the location of the Arctic Ocean? Has it always been way cold? Well, it means that one, either the Arctic Ocean can support tropical life, which we know is not true because it's way too cold, or the Arctic Ocean has not always been as north as we had thought. It might not be as north as we had thought, so it would have been down in the tropics. So that is evidence of climate change, meaning it was warmer down here and had a tropical fossil and then moved up north to the Arctic Ocean, and the fossil is still there. It's still there and impressed in the rock, but now the Arctic Ocean cannot support that life because it's too cold. So there was a climate change for the Arctic Ocean. It was in the tropics and had tropical fossils and then moved, and those tropical fossils are still there and it's cold now. So that's the idea there with climate change. And there's another piece of evidence for climate change. It says the climate was much colder in South Africa. Deep scratches in rocks showed that continental glaciers once covered South Africa. So this is South Africa. You gotta go south, and then of Africa. And it says that continental glaciers once covered South Africa. How do they know that? There's deep scratches in rocks. So there's deep scratches in rocks that could only be there by glaciers. What does that mean? It means that glaciers must have once covered South Africa. So now maybe the glaciers have melted away and Africa has moved more north, or the south of Africa has moved more north, and now there are not glaciers there. So those are the 4 important pieces of evidence. Let's review them. 1, the shapes of continents. 2, the evidence from land features. Those are mountains and coal beds. 3, the evidence from fossils. Those were the Glossopteris fern fossils, the Lysosaurus fossils, and the Mesosaurus fossils. We talked about the Lysosaurus fossils and the Glossopteris fossils. Then the 4th piece of evidence was evidence from climate change. And we talked about those tropical fossils found in the Arctic Ocean, which is wild because you can't have tropical fossils in the Arctic Ocean unless the Arctic was once, or an island in the Arctic was once in a tropical environment. And then we talked about those scratches in South Africa on rocks that showed that glaciers were once covering South Africa. So those are the four: climate change, fossils, land features, and shapes of continents. Now, we have some evidence to show that maybe the Earth was once all together in Pangaea. However, Alfred Wagner, so let me turn the page, he could not provide satisfactory explanation for the force that pushes or pulls the continents. So this means he had collected all of this evidence that supported his idea of Pangaea, but he still didn't know how the continents moved. So he thinks that they moved. He thinks that they moved, but he doesn't know how. And if you don't know how, then you cannot create this concrete idea. You can't say it's true. It doesn't make sense yet. So unfortunately, Alfred Wagner, he passed away, lived his life, but when he passed, it still was not considered a theory because he couldn't explain how continents could have moved. And so, luckily, you guys in the 6th grade will get to understand how continents move and how continental drift happened. So Alfred Wagner was responsible for the idea that it might have happened, but he couldn't explain how it happened. So that was unfortunate for him. But that is that. Now we shall continue on, and we will talk about that movement of continents and how continental drift happens. So try out the Check Your Understanding assignment and let me know if you have any questions.